I'm Patrick Ryan, and I get to kick us off with a spectacular faculty that have joined us today to provide this tutorial. So let's see. I don't even know where all my faculty are, but we've got Kristen Feeney-Koska is up here. We've got Anthony Senna. Where's Gautam? We've got Gautam somewhere in the room. And we've got Greg. Ooh, where's Greg? All right. And Greg is probably feverishly preparing the presentation he'll deliver to you later this afternoon. But collectively, we are here because we wanted to, as a group, provide you an introduction to the Odyssey Tools ecosystem. Basically, the intention of this tutorial is to give you all a little bit of exposure to a whole lot of possibilities. Actually, show of hands, how many of you are sticking around for an advanced tutorial on Saturday? Like half of you. Okay, great. So basically what we are doing in today's class is giving you a 30-minute version of what actually amounts to an 8-hour class for every single topic. So if you come away here saying, geez, I'm not an expert in each of those topics, that should be your expectation. You're not going to be an expert in all these topics, but hopefully you'll be excited enough to attend the tutorial on Saturday, listen to the videos, or participate in other Odyssey community activities. I want to specifically highlight, so this is going to be an interactive session. We're going to be actually doing some live demos with you guys, and you guys get to participate if you want. This URL that we put up here is actually a demonstration environment. I want to give a specific shout out to James Wiggins, who's sitting all the way in the back. James, thank you. So James works for Amazon Web Services, and what AWS has actually done, what James has done, is actually built an entire Odyssey ecosystem just for the purposes of you all in this class having the opportunity to play with the tools, which is pretty spectacular and remarkable. And if you just go to this URL, you're going to be playing with one of the main Odyssey tools, which is Atlas, that you're going to be able to get to play with yourself. And that environment is basically the same environment that if you and your organization install the Odyssey tools, it's the same experience that you would have as you would get if you came to my organization at J&J and were to play with that same tool. So thank you to James for setting that up for us. So if you are interested in taking advantage of this cloud-based environment that James has set up, he's actually written some beautiful blog posts about how to do it and how you could actually just use the image that he's created. And I'm sure I'll speak out of turn, but certainly if you're interested, go talk to James and he can definitely hook you up with it. I think what I am not a shill for Amazon, but what James has set up is freaking amazing, and you guys should take advantage of it. So there's the plug. We can send you that. Okay. So our plan for today, you guys registered. Everybody hold up your badges. Very cool. Okay. So you're all here. That badge will get you into today and tomorrow, and if you had a ticket for Saturday, that'll get you in there. What we'd like to do in this tutorial is, first I'd like to just walk you through kind of a very high-level overview of like what do we even mean when we talk about the Odyssey ecosystem and what we're trying to accomplish. And then all of us as faculty, we're basically going to go through individual components of the capabilities within the Odyssey ecosystem and show you what can be done and let you play along and experience it for yourself. So I'll give a brief overview of the vocabulary. Again, just to level set and disappoint you all up front, I'm giving you a 30-minute presentation of a vocabulary tutorial, which is being offered next door for 8 straight hours. So you're not going to get everything, but hopefully you'll kind of get the gist. We'll take a quick break, and then Kristen's going to walk you through how we can think about large-scale data characterization of databases, and we'll specifically highlight the Achilles tool in the data sources capability within Atlas. After that, Gautham's going to walk through cohort definitions and cohort characterization as a core capability within the framework. We'll take a break for lunch, which will be out in the foyer out there. And then after lunch, Kristen will come back and present about incidence rates and show you the capability of that within Atlas. Anthony is then going to take 2 full-day tutorials and collapse that into basically an hour. We're going to give you a 30-minute taster of thinking about population-level effect estimation, how to do causal inference from observational data, and then we'll also give you a 30-minute 30-minute tutorial on patient-level prediction and the exciting tools that are available within the OHDSi community. We're going to take another break, and then Greg is going to present how in the OHDSi community we're starting to form the basis of how to do network analyses across multiple institutions, and he'll showcase the ARACHNE tool that's being developed in the community. And then last, and I fully hope that this will be the most fun part, is as a group we're going to talk about how to actually use these tools and capabilities to answer questions that matter to you. And so we're going to spend the last hour working together, and the faculty will be around to help you with that. Just logistic thing. Can everybody see a screen okay? Does everybody mostly can see? Can everybody hear me? Give me a woo if you can hear me. Woo. All right, give me a louder woo if you can hear me better. All right, that was a lame woo. Give me a good woo. We need to get some energy going. Give me a good woo, one big good woo. All right, excellent, excellent. Now hopefully that class knows that we're the right tutorial. That's Gautam. Everybody say hi, Gautam. Hi, everybody. All right. So, any questions about what today's all about? Yes.
All right. So I'm a brand new person who don't know anything about this. Am I in the right spot?
So if you are a brand new person who knows nothing about this, you are in the absolute right spot. So these two tutorials, they're going on concurrently, but both of them are assuming no prerequisite knowledge. We're offering, this is the first time the organizing committee, we decided to do this to offer introductory tutorials prior to our main symposium, which is tomorrow, and then the advanced tutorials after. We may, as faculty, we may slip into some jargon that's not familiar to you just because we'll get a little lazy. But the intention of this class is that you don't have to know anything, but you're interested in learning more. I suspect for those of you who are brand new, some of this will make sense and some of it will seem like, geez, I need to go learn a lot more, which we will have done our job if we've given you enthusiasm to go learn more. And I suspect tomorrow at the symposium, a lot of what you learned today will kind of come into focus about how this actually fits into the community's efforts. Any other questions? Are we ready to get started? You know what you have to do if you want to get started. All right. Very good. All right, so let's talk about the overview of the OHDSi tools ecosystem. So at a high level, we all have, I hope anyway, that everyone's here, sees themselves as playing some role in a particular objective. And the objective that we as a community are focused on is how do we generate evidence from observational data? And the journey that we are on is trying to figure out how do we take patient-level observations captured during the routine course of healthcare and clinical research, and how do we take those observations that are being captured for other purposes and manipulate that data to conduct analyses that we can generate evidence that provides meaningful insights to actually shape what clinical care is all about. And so the reason OHDSi was formed and the reason we've come together is because many of us separately have been on this journey, continuously trying to take observational data and generate evidence. And what we've recognized is that that is a painful journey very often. It's a painful journey for researchers, it's a painful journey for data managers, and it's also a painful journey for the clinicians and patients who are waiting for good evidence to come forth. It's painful because it's hard technically, it's hard scientifically, it's hard from governance perspective, and it's also extremely resource intensive. And so given that we are all separately on this journey of trying to learn from observational data to generate evidence, several years ago we said, well, couldn't we figure out some way that instead of us all taking this journey by ourselves, we could as a community figure out how to work together so that we could share the pain and work together to try to figure out how to make this a little bit less painful. And so specifically we started thinking about like what are the things we could do to make the journey of navigating patient-level data a little bit better, and what else could we do to make the journey of conducting analysis on observational data a little bit more efficient and a little bit more reliable. And so on this particular journey, what we recognize in the community is we have a lot of different stakeholders who have a lot of different ideas of what data they might want to be working with, and also a lot of different perspectives of what types of analyses can be performed. Just to lay this out, I want to share with you some of the perspectives that we see and hear from the community, being explicit that this is an open community so that all perspectives are welcome and encouraged. And part of us, the reason we're providing these tutorials is to expand that community and expand those perspectives. So really on two sides, we're trying to go from data to get to evidence. And one of the things we need to recognize is that there's lots of different types of data that we might think about in terms of data we might want to try to analyze. We can think about the dimensions of data from the perspective of there may be different populations that we're interested in studying, whether that be patient populations representing a pediatric population or an elderly population, maybe populations that represent different socioeconomic representation. We notice that there is data coming from various different care settings. We see data that's coming from ambulatory care and outpatient visits, from general practitioners or from specialists. We see data that's being captured in the hospital setting, whether it be in emergency rooms or ICUs or inpatient admissions. We see the coordination of care happening within systems, whether it be primary care physicians that are then referring patients to other secondary centers. And each of those care settings means something different from the origin of the data. We also have different data capture processes that we're thinking about. So many folks in the community are actively using administrative claims from insurance systems and thinking about the fact that these data are captured for reimbursement purposes, but how can we use them in a secondary use to learn something clinically? Several folks in the community are really actively using electronic health record systems, whether it be the hospital setting that they are particularly in or an ambulatory care electronic health record. Still others in the community are really thinking about how we grapple with observational data that's captured for clinical research purposes. So think about clinical registries where we're prospectively capturing data and trying to figure out how do we exploit that data to learn as much as we can, even in the context of clinical research. The other dynamics that's really important is that the health system itself can actually matter quite a bit, whether we're talking about patients who are insured or uninsured or country policies. Importantly, for those of you who are new, OHDSi is very deliberately an international community. We have representation in, I think, like 20 countries of organizations that are actively participating in trying to do. And one of the most exciting things for me, anyway, as a researcher, has been to learn from the disparities that we observe across the world. If you are in your own local country and you wonder, geez, I wonder if there's a better way to be providing care, the OHDSi community provides you a place to actually ask that question and try to learn from that. And what we've already seen in a lot of our research is that there are tremendous differences in how care is being delivered around the world, and we can learn a lot from those differences. So that's on the side of data. We're thinking about how do we come up with shared practices and standard approaches given these very differences that we see across the community. On the flip side, we see that there's lots of different types of evidence that the community wants to be able to generate. One use case that we've seen a lot of interest in is, can we use observational data to support the clinical research apparatus? And we can think about that from a vantage point of cohort identification. Can we find people using these observational data systems that we could then use in a clinical research context? And so there's work in terms of thinking about things like clinical trial feasibility and recruitment to use data to find patients so that you could then go do something else with them. But of course, it's not always about prospective outreach. We can also just learn from the data itself. And from that, within the OHDSi community, we really have had a lot of focus on three main analytic use cases. The first being clinical characterization. Think about this as descriptive summary statistics. We want to be interested in treatment utilization. Who takes what medical interventions in what order? We want to think about disease natural history. So who are the people that have a disease, and what do they look like before they got disease? What do they look like as they're being treated for their disease, and what do they look like as the disease progresses? We've seen a lot of excitement in the community around quality improvement and thinking about how we can use data to summarize the performance of health systems. A second analytic use case has been population level effect estimation, or thinking about causal inference. And we've seen two primary use cases that have gotten a lot of attention within the community. One has been safety surveillance. So thinking about, for any given medical intervention, does that medical intervention actually potentially increase the risk of some sort of a harm? So for example, if you were to take a prescription drug, does it cause an adverse side effect? And we want to have methods that can actually use our observational data to try to answer that question about whether or not medical interventions have risks that should be adequately communicated. The second area of interest has been comparative effectiveness. So in the space where you are looking for treatment alternatives, it's very logical to ask which treatment alternative would be best for me, and to think about how to make comparisons between alternative treatments and being able to collectively summarize the benefits and potential harms, comparative harms of those treatments is something that we've put a lot of time into thinking about. The third analytic use case and an area that I'm personally very excited about is patient-level prediction. So it's one thing to be able to say that a medical intervention has an effect. It's another thing to say whether or not that particular effect is going to happen to me. And so within the OHDSi community, there's been a lot of exciting development in trying to develop strategies to use these observational data to answer questions around precision medicine, so, which patients are going to experience what type of outcomes when given certain interventions, and also disease interception. So, can we actually identify who's going to develop a disease before it ever happens, and potentially intervene and improve their life using predictive analytics as a foundation for that. So, we've got lots of different data in the community. I'm sure some of you in the room may even have other types of data that you're interested in. We've got lots of different analytic use cases that the community is working on, and I am 100% confident that this list is going to continue to expand. What today's tutorial really is about, though, is given that there's different data and given that there's different needs, how can we as a community come together to think about shared practices that would allow us to develop analytics to answer some of these questions on some of the data that's available in an efficient and reproducible way. So, I promised you guys that this would be interactive. And we want to start, before telling you about all the cool things you could do, we want to start by hearing from you guys about what your questions really are. And so we were talking last night about this, and we thought one of the nice things about us having a diverse faculty here is we're all coming from very different perspectives across the OHDSi community. And so we thought first we would just each share a quick sentence about the research questions that motivated us to join the OHDSi community and to participate in this journey. And then what we'd like to hear from you guys is, like, why are you here? What kinds of problems are you looking to address? And Anthony's going to be captured on the whiteboard as we go. So I'll start. So my day job, I work at Janssen Research and Development. I head up our epidemiology analytics team. And that is a team that reports up to our chief medical officer within Johnson & Johnson. And our chief medical officer has been very explicit that my job is to protect the safety of patients. And so my responsibility is to try to see what we can learn from observational data to better understand our knowledge about J&J's medical products, and to make sure that if those products have knowledge that we don't yet know from clinical development or otherwise, that we generate that knowledge and disseminate it so that patients can make informed decisions. So a lot of my focus has been in the population level effect estimation space, thinking specifically about drug safety surveillance. But we've actively within our group really transitioned to think about how to go from learning that a product might have a side effect to thinking about how can we more proactively communicate to patients about which patients are most at risk for those side effects. And so from my vantage point, if you ever hear me get loose in my language about not just talking generically about exposures, I might slip into using the word drug, and that's just because my frame of reference in the work that I started with comes from pharmaceutical research. Gautam, you want to share your perspective?
Yeah, so can you all hear me, or should I go up the meeting?
Hey, come on up here.
So I work for Blue Cross Blue Shield of South Carolina. It's a health insurance company in the U.S. My title is Chief Medical Informatics Officer. So I was in this position for 4 or 5 years when I snuck into one of the OHDSi symposiums in 2016, having no idea what it was. And my wife, she works for the Medical University of South Carolina, and she was an OHDSi symposium attendee, and I was the +1. So I came in, and I was watching Patrick speak and a few other OHDSi symposium, OHDSi leaders, the community leaders speak, and I was able to say, oh my God, this is exactly what we need. We are not a research organization. We don't we don't look for evidence for new services. We try to figure out what is the best way to deliver services. So we are on the service delivery side, and some of the things that we are responsible for are, one, how do you do good population health? How do we identify the people who are at risk or at the top of the pyramid, risk of being admitted to the hospital, risk of decompensating from a congestive heart failure? How do we find them and call them, help them through services by working with providers or through our call center? That's one use case, population health. We sell insurance. We sell insurance to groups of people called employers like a big tire company or a big industry in a local area. And that population, we are responsible to manage their health. And so as part of our contract, we describe and characterize the population and say, this is the number of people who have these types of diseases. These are the people who have these types of drugs. And if you change your benefit design, that's going to help them much better. That's going to reduce your cost. It's going to improve the quality. How do you do that? How do you characterize the population? And then the third one was what we call as active surveillance, where if we have a population that has a slightly increased disease burden of certain things like HIV or diabetes, we want to know that. How do we know that one cohort of people is different from another cohort of people? So as I was listening to Patrick and others speak in 2016, this was the use case that we went ahead and solved. So this is not a research use case. We would like to know your use cases too. There are research, non-research use cases.
Very good. I work for Deloitte, and a lot of people say, what is Deloitte doing here? Well, I should probably say my first hat is Odyssey collaborator. My second hat is my employer. I am an epidemiologist by training. I have my master's in public health and epi. I actually used to run clinical trials at Beth Israel Deaconess in Boston. I did that for quite a few years while I got my master's. Worked across the cardiovascular space, worked on some Janssen drugs even. So I do see the world in molecules because that's also where I started to my research. I left that job and went into Medicare risk adjustment, learned a lot about how we qualify people's risks and how we see people between their payer and their provider. And then I came into consulting and I realized that there was this really cool symposium that I knew nothing about, a lot like Gautam. Somebody just said, hey, Kristen, can you go to this for a day? It was also this was the first year, was that 2015? I forget, time kind of flies when you're having fun. But I stumbled in here and this became a community that made sense to all the things I had done without having a title for it. My passion is in patient level prediction as well. I spend a lot of time working on machine learning models on top of real world data, and using the CDM and the vocabulary is to create a standard framework so we can externally validate our models. So that's my passion, that's me. That is somewhat of my employer, but mostly me as an individual.
Thanks, Kristen. Anthony, you want to?
I don't know if I speak as loud as everyone else, but so I'm Anthony Sun. I'm part of Janssen Research and Development, part of Patrick's team there. My research questions are really focused around the needs of our epidemiology group. So I spent a lot of time listening to the types of questions that are posed and thinking about how we can extend the open source tools that you're going to hear about today to help answer those questions in ways that make things more efficient and standardized in our tools. So when we engage with some of our colleagues in our department to answer questions, part of me is thinking about how to answer that question, and another part of me is thinking about how to continue to improve those tools to make that question easier the next time it's asked.
Greg, you want to shout from the back? You got to scream, Greg. Or come up here. Come up here.
I'm here because, our company is focused on creating solutions for observational research. And my specific passion, as I said, is life sciences. My dream and my hope that we will be able to contribute to Odyssey, and as part of this contribution, we'll be able to be part of the team focused on creating new novel treatments, whether it's in pharma or helping out healthcare organizations to provide better treatment of patients.
So we really want to hear from you guys. Why are you here? What questions are you encountering that you are hoping to learn about how to answer? We got one in the back. Yep. Oh, do we have a microphone? Yeah, you go ahead and scream, and I'll repeat it. Right. So the two use cases I heard, just to repeat and to get it on the camera. So one is really about measuring outcomes in terms of systems, and then value-based transformation, really trying to understand how can we actually delineate that chain through the entire healthcare system in terms of outcomes, process and outcomes. Ah. Got it. Got it. So it's also connecting it to the Institute of Medicine quality framework. So you're really looking for how do we actually bring those measurements also to the incentives associated with effectiveness and safety and quality and cost. Very good. Thank you. Very good. So just for the posterity of the recording, so heard two things that are important there. So for those of you who are not aware, the All of Us program is a very large NIH program that's trying to collect electronic health record data and genetic data about 1 million patients. And so that is actually using the OMOP common data model as a back-end foundation for that. And then separately within the institution, this idea of just creating cohorts, finding the people that you want to do research on, and creating that in an efficient way is a compelling use case so that then researchers can do whatever they want once they've got those cohorts. Got it. So thinking about the various data standards that are out there and how to kind of navigate that space. I'll just comment very quickly on that. To learn more about that, the room right there, they are talking about the different data models. And so there is some content that's available. But very, very quickly there are alternative ways to standardize observational data, really predicated on the use cases of those respective communities. So the use cases that I outlined, the idea that we are trying to be an international data model, the fact that we are trying to support a lot of different use cases is something that is differentiated from some of the existing models that are U.S. focused, either just for claims or just for EHR or whatnot. Not that they're better or worse, but each of those communities kind of has a focus and a priority. As it relates specifically to FHIR as a data exchange work, there's actually a very active OHDSi work group focused on specifically how do you take data that's in an OMOP CDM and use the FHIR standard to actually be able to facilitate patient exchange of analytics. And so from that perspective, those are very complementary standards, not something that's an either or. Yeah, in today's tutorial specifically, we probably won't get into all that much of that, though the one next door is going to cover that. I think Andrew's data quality class, you're going to learn a lot from the different networks and all the perspectives of that. And certainly you'll see tomorrow in the main symposium, there's several posters that actually really are trying to dig into that. So I hope you will get a lot of that throughout the next couple of days. Alan? Thank you, Alan. So for the record, so Alan's a FDA and is talking about our collaboration in hemovigilance and thinking about both the task of how to use observational data to create robust phenotypes, but also how we actually can extract data out of these electronic systems to actually be able to identify adverse event cases and report that as part of our overall national vigilance system. Yeah, so a compelling problem that we have a very nice structured data model that supports structured data, and the challenge is, yeah, but that only represents a small fraction of the actual data. And so the OMOP common data model and some of what's kind of covered over there is the fact that we can accommodate the storage of unstructured data, but as long as it remains unstructured, you've got a challenge of how to do that. And so there's various work groups within the OHDSi community with a shared interest in trying to tackle that and developing shared processes for natural language processing and for the annotation of unstructured data to create structure that can then feed as inputs into the analysis tools that you're going to see that we go through today. So Johannes' use case in Denmark is really about how to take advantage of national data to provide point-of-care applications. A specific example, patient-level prediction, trying to figure out post-operative complications in patients with colorectal cancer. Great, thank you. Yeah, so specifically thinking about how can we learn about clinical care to help with prioritization of resources in trauma care units or in geographic areas is something that's of shared interest, yeah. Hopefully this gives you a perspective that y'all are coming from very different perspectives, and that's great. That's exactly why we have created this community, is to have diverse perspectives coming to the table to try to learn together. And part of the reason we do these tutorials and hold this symposium is because it provides a great opportunity for us to learn from each other about these cases. What we're going to present here is a set of tools, and with with apologies that we might get caught into a little bit of a jargon, what we've realized is despite all of those very different analytic use cases, there are some core basic ideas of how to analyze observational data that appear to us, at least thus far, are pretty universal to thinking about how to go from data to get to evidence. And we would like to share with you some of the tools that have been built from the perspective of hopefully giving you some stimulus to think about how they might apply to your various analytic use cases. So one of the things that we do is I said that the journey goes from data to evidence. And one of the things that we very logically do in the community is we try to split that journey in two halves. There's the process to go from data to standardized data, which in the OHDSi community, we've adopted the open community standard of the OMOP Common Data Model. And then once you will have standardized data to produce standardized analytics. I will highlight that if you are interested in going from your raw data to standardized data using the OMOP Common Data Model, there's a wealth of open source tools that have been developed within the OHDSi community that are available to help that process. And specifically, if that's of your interest, then after today's over, you should watch the video from next door because they are really going through the process of explaining all of that. And within today's class, we are not going to cover tools to get you to a common data model, but rather presume you have data standardized in this format. We will show you the Achilles tool, though. Kristen will go through that to show you how you could characterize data once it's standardized. Just one other, just a logistic thing. I see a couple people taking pictures of the slides. Just to be clear, all of the material we're generating here is public domain because everything OHDSi does is public domain. All of these slides are going to be posted online right after the session. And so you can get a copy of them and download them. Yes? Yeah, so the question was about in this ETL design, we've got two tools that listed there, White Rabbit and Rabbit in a Hat. So specifically, we have developed a generic utility that allows you to point to any source database, and it will basically characterize what are the tables and the fields and the content of that data so that you have a profile of the source data to think about how are you going to design your ETL to take that source and get it into the common data model. Okay, so Dan, yep. And ETL is extract, transform, and load. It's the process you need to follow to go from your source into the standard. And so if you are interested in this, there's lots of good resources. For today's class, we are going to assume that you've done this. And if you haven't yet done this, we hope that today's class will be the motivation for you to go back and do it. That standard that we're talking about is the OMOP Common Data Model. This is our latest cartoon. This is OMOP Common Data Model version 6, which was just released today. So there you go. This is actually a big milestone for us. So yeah, I think even half of the faculty hasn't even seen this slide. So there you go. It's fresh off the presses. But the main point to actually reinforce here is that to your question about like data models. As one of the people who actually created this, I will be the first to say that I don't actually care about which common data model you use, but I care very passionately about that we need to have a common data model, and the focus is actually not on the DM, but on the C. It's about common, it's about community. It's about actually us agreeing to standards that we can all follow and agree to together, because it's only by having those standards and a shared consensus about what's being done that you can actually use that as the foundation to build all the analytics you're about to see. And so this is the model we are using in this community, but it is an evolving open community standard, and it is evolving based on the community's interests and needs. And so this cartoon simply represents that what we're talking about is a way to store patient-level observations. So things like, for a given individual, when do they have health encounters, what procedures are administered, what conditions occur, what drugs or devices are they exposed to, what measurements may be provided, such as laboratory tests. That unstructured data, we've got ways to store both the unstructured free text notes as well as processed NLP artifacts pulled out of those notes. A recent introduction is to support patient-reported outcomes and surveys, to capture biobanking information about specimens, We also have standardized how we represent health system information. We've standardized how we think about health economics. We've standardized derived elements that we just find repeatedly get used in a lot of our analytics. And on top of this, we have imposed not just a standardized structure, meaning the data tables and the fields, but also standardized the content by imposing a standardized vocabulary throughout this data model. The main thing, yes, question?
Might be, what's OMOP? What does OMOP stand for?
Sure, yeah, so OMOP at this point is just a legacy acronym, but it was the Observational Medical Outcomes Partnership, and this was a public-private partnership chaired by the FDA, whose focus was try to learn about how we can use observational data to support FDA's specific use case, which was medical product safety surveillance. The original OMOP Common Data Model versions 1, 2, 3, and 4 were, actually 1, 2, 3 were designed specifically to meet FDA's needs. And then version 4 came around and the community recognized that they also wanted to support the efforts of PCORI and comparative effectiveness research. And so it expanded pretty radically from there. And since then, the OHDSi community has been the group that has been stewarding this open community standard, and it's evolved to support other use cases such as health economics and patient reported outcomes, et cetera. So it still has attached to it the original brand name that it started with, but at this point it's just a data model in GitHub that anybody can download. Yes?
Is that table survey conduct new?
Yes, survey conduct is new in version 6. So this was something that the community had designed while we were still all on version 5, voted on and ratified, and its release comes with this version 6.
So it's survey of patients or of providers such as doctors answering surveys?
So the survey conduct table basically stores the fact that that a survey was conducted on a patient at a moment in time. The specific questions and then the answers to those questions all get stored in the observation table as question-answer pairs. And so this is the shared conventions that we as a community designed to support that expanded use case around survey research and clinical research and patient-reported outcomes.
Hey, Patrick, is OMOP an incremental data model?
So thank you, Kristen. So yeah, a lot of people ask this question about like, well, what am I using this common data model for? And we heard Sam mention like, you know, he's an expert in data warehousing. We have seen across the community people using this data model in a lot of different ways. When it was originally developed and conceived, it was thought to be an analytic layer that you could lay on top of your source data to provide more efficient ways to conduct analysis. So it was not designed to be the replacement of your existing data warehouse or your existing EHR system or something like that. That's not what it was designed for. It was also designed only to support observational data, patient-level observational data. However, the community has evolved considerably, and some people are just using this as their data warehouse. Some people are storing clinical trial data sets in there, and the community is having active conversations about all of those things all the time. But again, and to this early point, a common data model, well, if you were in that class over there, you'd be talking about that the common data model is the end game, because that's where they're trying to get to. In this class, the common data model is simply the means to an end. We got to standardize our data so that we can think about standardizing our process of generating evidence. Right. Okay, so flipping to the second half of this question, we want to be able to structure the journey from getting from a common data model to evidence. And what we've seen across the community is that there's a lot of different ways that people think about wanting to generate evidence, and there's lots of modalities that we would potentially like to support. So just as an example, the most traditional way that we see research get done is some person has a particular question. Like Giannis's group has a specific question about what's going on with postoperative complications after surgery for colorectal cancer, in which case one could think about that one clinical question, sit down and write a protocol. Once the protocol was written, some analyst could sit down and write code. That code could be run against a database. That code would hopefully generate some aggregate summary statistics. Those statistics could then get written up in a journal article and published, and that could be the process of generating evidence. Show of hands if that's the process that you guys are familiar with. Okay, so about half of you, that resonates a little bit. So another modality that we've seen in the community is this idea of real-time querying. So if there's a type of question that you just want to ask repeatedly, one could think about developing some sort of an application that supports that specific use case, such that we'd have a designed instance of a tool that performs a particular task, and then we could just design a particular example of that, submit a job, and get results and review the results. So an example of this could be, Sam mentioned, like, we just got to be able to create cohorts. And what we've learned in the community is, like, creating cohorts is a shared pain that we all have. And so we think about, like, can we develop an application that allows us to construct cohorts in an efficient way, that so long as we have a standardized way of doing that, everybody can learn that capability and can use tools to perform that task in a repeatable fashion. The other, so just curious, like, how many of you are motivated by the idea of, like, having real-time query capabilities? Okay, that was more distributedly weighted towards the front of the room. The back of the room is less of a real-time query crowd. Okay, the other use case that we've been really thinking a lot about is how to actually really transform how we generate evidence to get away from or to go beyond asking one question and getting one answer, and to think about how we can systematically explore all the possible questions that any researcher might want to ask against the data set. And so in this particular modality, we're thinking about large-scale analytics. We're thinking about how could we build a tool that's going to answer all the questions anybody could possibly imagine, and then enable users to actually explore the space of evidence. So instead of exploring data, we start exploring answers. And the idea here is that we actually, what we really want to be in the business of is getting evidence out in the hands of people who need to make decisions. And so to do that, we need to think about novel ways of generating evidence at a scale that's really never been done before. I will just say that I will be disappointed if you all, so actually, show of hands, how many of you find that a compelling use case in your organization right now? Only maybe about a third of you. Okay. I will be very, very disappointed if by the end of tomorrow's symposium, you are not all going back to your organization saying that this is the future of healthcare analytics. Just leave that teaser for you. Okay. So what we're going to spend a lot of time today on is the OHDSi ecosystem, the set of tools that have been developed by the community. And I'm just going to introduce them to you very quickly so that we can then dig into the features. One tool is a tool called Atlas, and this is an open source platform to allow you to design and execute observational analyses. This is the tool that we're going to show you a lot of these particular functions, and this is the tool that James set up the demo environment. So if you went to that URL that we had up earlier, and we'll show it again for you, but if you go to that tool, you'll be in Atlas, which is this platform. Yep.
When you said design and execute analysis, is this an analysis against the common data model?
Yeah, so everything from now on, we are going to presume your data is in the OMOP common data model. And all of these tools are going to be predicated on the fact that that's what exists. Yep. So inside of Atlas, on the left-hand side, you're going to see this kind of long menu of functions. And I'm just going to rattle through them real quickly now, just so you can understand the breadth of what's available within this platform. So we have a tool called Data Sources, which Kristen's going to present, and we'll present also the standalone version of Achilles. But basically, this is a tool to just descriptively characterize your population. We have a vocabulary search that allows you to actually navigate and explore the standardized vocabularies that serves as the foundation of our common data model. We have a concept set capability so that you can actually group these different vocabulary entities together and create logical clinical units that you want to study. We have a cohort definition tool. So Sam said he needs to have a standardized way to create cohorts. So this is going to be the thing for him. Because cohort definitions is basically the ability for you to construct logic that allows you to define the set of people who satisfy criteria for some span of time. And Gautam's going to present exactly how that actually works. We have a cohort characterization tool that basically allows you to say, given that you have a population that you're interested in, let's provide descriptive summaries of those people. So what are their baseline characteristics, their demographics, their comorbidities, their concomitant medications, and allows you to generate those statistics for one or more cohorts and even compare cohorts against one another. We have a tool called Cohort Pathways. This is newly released for this year's symposium. For anybody who happened to have read the OHDSi paper about treatment pathways, we had this idea that we would like to be able to explore the sequence of treatments for any particular given disease, and now we have an analytic capability to introduce that. We have a tool for incidence rate. So given a population, you'd like to know what proportion of those populations go on to have some secondary outcome. And Kristen's going to show you how that actually works. We have a tool for showing patient profiles. So imagine you actually had an individual case of an individual, and you wanted to say, like, what data do I actually have about that individual? So this is actually a tool that allows you to see all of the data that's in the common data model for an individual in a graphical and tabular format. We've got a tool for population level effect estimation. So Anthony is going to walk you through how you can actually use this web-based user click interface to actually design pretty extraordinarily complex analyses for doing causal inference. And the user interface that you're just going to click through will actually generate an R package to allow you to execute that study against your common data model. I got one wow face. That's good. I like the one wow face. I'm looking for more wow faces. But that's good. You get it. The next one is patient level prediction. So you hear all the buzz about deep learning and machine learning. Well, what we've actually got in the OHDSi community is, again, a user interface to allow you to design and specify a prediction problem, whether that be using a lasso logistic regression or a random forest or a deep learning algorithm. And again, you can fully specify the problem in the Atlas user interface and then download an R package that will actually learn and validate that model against databases around the world. So those are the capabilities of Atlas. Each one of those can and does actually represent an entire day curriculum to learn about it, but we're just going to give you a taste of each one of those today. Yes?
Could you explain how you guys use concept? I noticed that in a lot of your literature, and it was a little different than most data administrators would use concept.
Yeah, so thank you for the first check of jargon. So the first presentation I'll give after we get through this overview is actually about the vocabulary, and I really will try to introduce that concept we mean in a very specific way, which is a unique identifier representing some medical entity that exists within the common data model. And so if it's still confusing after the vocabulary talk, then please yell at me again. Yeah.
I'm not sure if this is in scope for what we're going to talk about today at all. You're saying you're saying we're going to skip the ETL step and jump to Atlas, and I sort of want to know, at least in an outline, what are the technologies involved when you do ETL? Do you get the data as CSV files, or do you get them from an SQL database, or do you get them in some other format? How do you load them? How does it transform them into that common data model? Overview, like, what do about 50% of it? What does 50% of the community do by and large?
Sure.
What happens?
Sure. So I'll tell you about where we're starting from, which is, so you now have your data in the common data model. What does that actually mean from a technical perspective? So the common data model is a relational database. So you need to be stored in a relational database format. Within the OHDSi community, people are using a lot of different types of relational database technical environments, and all of these tools that you're going to get to play with, we're trying to accommodate a large set of those technologies. Specifically, the relational database environments that we cover, let's make sure I get the whole list. We're supporting Microsoft SQL Server, Postgres, Oracle, Redshift, Hadoop Impala, Microsoft PDW, Netezza. That's Oracle. Did I say Oracle? So what does that mean? So if any of you are saying, well, my data is just in a CSV, isn't that good enough? The answer is no. I would say what you should do is import that CSV into a Postgres database because it's free, or get Redshift because it'll be way more performant. If you are saying, yeah, but my data's in SAS and I'm just a SAS programmer, I will remind you, you are at an open source community and an open science community that does everything in open code. And so we don't do SAS here. There's nothing wrong if you do SAS, but a common data model in SAS format won't work for these tools. But as long as you get your data from whatever it starts in into a relational database of one of those flavors, then the tools you're going to get to play with here will be supported.
So, again, I'm sorry to take so much time, but, ETL, when you do an ETL step, which is extract, transform, load, let's say I'm loading it from an EMR, because that's what I work with. You basically take the data from the EMR, however the EMR exposes it to you, maybe via a web service and Fire or something, and you use some code to store it into a relational database in the common model. Is that what happens?
Yeah, so across the community, there's a lot of different technologies and approaches that are being used to go from the source data in whatever format it might be into this OMOP common data model. That is out of scope for this class, though. That class is talking about how to do that ETL. But there are tools available. But one of the things we've learned about the diversity of the community is there is no one technology to do ETL. That's been something that's kind of been a unique process for everybody. So we try to facilitate a process for doing ETL, but not be prescriptive of a technology solution. Where we are going to be prescriptive of a technology solution, though, is your common data model does need to be in a relational database. It needs to follow the common data model conventions. And then the open tools that we're going to show, including Atlas and ARACHNE, these are open source software platforms that are available on GitHub that you can download and install in your own local environment. So there's no proprietary software involved. So everything we're using is Apache 2. Yep. Yep. Okay, so I just mentioned Atlas, and we're going to spend a lot of time on that. I just want to highlight that you're going to get to play with the fun part, which is the front-end user interface. But behind that front part is actually a large library of back-end statistical packages and analytic routines that have been developed. So we have developed, and you can get them out of GitHub, various tools for everything from how do we have one standard way to connect to those 7 different database environments. We had to actually write a package to do that. How do you actually take an SQL statement that's written for one environment and actually translate it to work with the different peculiarity languages across the different things? We had to write a package for that. We've written statistical packages in R for conducting these large-scale analyses. And so all of these are available on the OHDSi GitHub repository. You're basically going to be the beneficiaries of them through the Atlas user interface. The other thing I'll just introduce that Greg will present at the end of the day is that we're not just trying to help you as an organization do your own analysis in your own institution, but we're hoping to encourage you to become part of a network and to participate in international research. And so the ARACHNE platform that Greg will introduce is basically a tool to enable network analyses. So you can design your study in your own environment, you can generate your own results, but then you're going to want to ask yourself the question, like, how does this result hold up if I apply the same analysis in Korea or the Netherlands or Australia or California or any of those crazy places. And so ARACHNE is a capability within the community to allow that network analysis to take place. So all of this stuff is freely available. So you get what you pay for. Yeah, let's give it a woo. Let's give it a woo. So if you just go out to github.com/OHDSi, you'll see all of these packages in various forms. But that is a core central tenet of everything we're doing in the OHDSi community is this stuff needs to be free because it's by the community for the community. Okay. Okay. So I just want to, so I gave you kind of a high-level abstract idea of all of these capabilities, and I hope some of them kind of make sense, or you could imagine how it fits into your world. But I want to give a blazingly fast, like 6 minutes or less, summary in a very tangible way of what these tools could potentially do. And to illustrate this, I'm just going to provide the example of a published paper. Okay, so the screenshot here is a paper that was published by the FDA. It's actually a quite nice paper, and we use it in our tutorials because we think it's a nice demonstration of an example of a population-level effect estimation study. So specifically, it was a study that was comparing 2 different drugs. warfarin and dabigatran, which are two drugs for atrial fibrillation. And it's a study that was actually comparing the benefits and risks of those drugs in terms of which of those drugs might reduce the risk of stroke and increase the risk of bleeding. And so this was a study that was commissioned by the FDA, and they did the traditional single study paradigm where they came up with a question, they got their data, they conducted an analysis, they generated the results, and then they disseminated it through this very well done publication that was published a couple years ago in Circulation. The reason, but I hope that you could see, like, this is just a paper. Many of you have published papers or have read tons of papers, and it's just another paper that represents using observational data to answer a clinical question that matters. In this particular case, mattered to the FDA, and certainly for this question, matters a lot to patients around the world who have atrial fibrillation and have to make choices about what treatments to take. So, just to decompose, like, what are the elements of a paper? Like, what kind of stuff would you put in a paper that makes sense? Well, one of the things that's very typical in a paper, and very often it's table 1 of the paper, is some characterization of the population that you want to study. So in this particular paper, they summarize that there's people on dabigatran and people on warfarin, and we had a descriptive characterization of demographics and medical history and drug utilization, and it kind of spanned on. So a table 1 of descriptive summaries of a population is something we might want to have. So we can imagine that's in a paper. Table 2 of this paper told us about the incidence of outcomes that occurred in these populations. So, it gave us just a summary of how many people had each of these different types of events and what is that incidence rate computed to be. So a very typical kind of question is, I'm interested in people with warfarin and how many of them go on to have a stroke. So not only do I want to characterize who are the people that take warfarin, but I also want to know how many strokes occurred after I took warfarin. And that's the kind of information that we would typically see in a paper. Another part of that table, actually, in this particular case, though, is they weren't just providing an incidence rate, but they were providing a statistical test to compare the ratio of the incidence rates in the warfarin group with the incidence rates in the dabigatran group. And so they computed hazard ratios as a population level effect estimation, and they basically were able to tell us whether or not warfarin or dabigatran was different in terms of their the outcomes associated with those exposures. And so producing those types of effect estimates is the kind of thing we might expect to see in a study, certainly a study for population level effect estimation. So there's just 3 components there. You've got characterization, you've got incidence rate, and you've got population level effect estimation. And what we've realized across the community is we see these things that kind of repeatedly, no matter what one of your use cases are, these things just come up over and over again. So if you want to do a characterization and you just want to understand a population, what do you need if that's the output we want? We want to produce a table 1. Well, what do you need as an input? You basically need to have a cohort. You need to have those people who are on warfarin to be able to summarize that. And specifically in that table, we needed 2 cohorts. We needed the target cohort and we needed a comparator cohort so that we could compare those things together. It's also possible, though, we would want to characterize the outcome. So who are these people that have ischemic stroke? In which case we could create another cohort, people with ischemic stroke, and be able to characterize them. And then when we talk about disease natural history, that's really all we're talking about. Turns out that now we've got these 3 inputs. You've got a target cohort and a comparator cohort and an outcome cohort. Now that we have those artifacts, we can answer other questions. So specifically, we can create an incidence rate summary because we basically just need to know how many of the people in the outcome cohort follow the initiation in the target or comparator cohort. We can also do population level effect estimation. So these become the same inputs that go into those large-scale models that Anthony's going to present in a little bit. So if you want to estimate the relative risk of alternative treatments, you can just use these cohorts as the input. And what's not covered in that paper, but is certainly something that we hope to introduce for you today, is patient-level prediction. So that paper basically talked about whether or not warfarin had an increased risk of stroke relative to dabigatran. But if I'm the patient talking to my clinician and I'm about to be prescribed warfarin, I want to know, hey, doc, what's the chance that I'm going to be the one that has the stroke? And so it turns out that we can actually solve that problem too using the exact same inputs of these cohorts. And so I lay this out because Gautam's going to talk about how to build cohorts. Those cohorts are then going to serve as an input to characterization, to incidence that Kristen's going to show, and to both estimation and prediction, which is what Anthony's going to show. And so while we're going to cover a lot of things, we think it's possible to introduce this class to all of you because you only really need to learn some basic principles that are going to be kind of applicable across this entire toolkit. So just to give you the last teaser about it, in Atlas, you're going to be able to create a cohort of people who are new users of warfarin. In Atlas, you're going to be able to do cohort characterization to compare new users of warfarin versus new users of dabigatran. And you're even going to be able to get visual plots that actually show you what the differences are in those populations. In Atlas, you're going to be able to specify an incidence rate to be able to say, for those warfarin and dabigatran users, what's that risk of stroke and bleeding and intracranial hemorrhage? And you're going to be able to actually stratify those results so you can actually see the incidence rates across different populations. In Atlas, you're going to be able to design population-level effect estimation studies. So actually take that paper and read it and see all of those particular nuances of that analytics. Anthony will show you how you can actually just answer those questions through a form and generate an R package that would execute that exact same study. And the output of that study would be things like a propensity score matched new user cohort design. And you'd be able to evaluate the distribution of a propensity score overlap. You'll be able to get a standardized attrition diagram that shows you, how'd you lose your people when you conducted this study. You're going to be able to see diagnostics around covariate balance and how similar are those groups in that study. You're going to be able to ultimately produce effect estimates, just like you would see in a paper, that are going to be able to summarize exactly what happens. You'll even be able to get nice, pretty visuals of Kaplan-Meier plots to show whether or not these drugs are different. So this is standardized output that are coming from this standardized analytic platform that you're going to be introduced to today. And just to take it one step, Anthony will also show you how that we can also pivot that question to a patient-level prediction study and be able to take that exact same question in Atlas and say, amongst people with warfarin, which are the ones that are going to have a stroke? And we can apply then machine learning algorithms to that problem across data. And the output of this is not only standardized visualizations that we could put into a publication, but actually we've taken it one step further with patient-level prediction. The output of the package is actually itself an interactive web page for you to explore the results. And this is an ARACHNE app that the tool produces that allows you to see things like the performance characteristics of the tool. What we plan to go through today is a very, very deliberate whirlwind tour through all of these capabilities. We hope that all of them will be of some interest to all of you, and hopefully some of them will spark enthusiasm for you to learn more about each of the capabilities. So before I dive into vocabulary, let me just stop and see if there's any questions. Are we still? Oh, we got a question up right back. Yep. Oh, and we have a mic now. Look at that. Cool, very cool. Technology, innovation in technology, it can happen continuously.
With this particular study about warfarin, I'm interested about comorbidities and risk factors because patients taking warfarin, pretty sick patients, sometimes they are old. My father had, taking warfarin, but he has chronic kidney disease, chronic CKD, CLD, lung disease, and diabetes, and so on. Then you get into drug-to-drug interaction because you get primary diagnosis, secondary diagnosis, right? And then for primary diagnosis, you take a number of drugs for different disease. Then you get into drug-to-drug pathways, right? Mm-hmm. So when you get into that, because you need to determine this caused this, right? A caused B. Yep. He's taking warfarin, you get into stroke. You're taking warfarin, you get into heart attack. When you get into that, you get into epidemiology study like Markov chain models. Mm-hmm. So will you talk about those kind of care pathways and drug pathways, either using Monte Carlo simulation or at least Markov chain models where you go from drug to drug pathways?
Yeah, so maybe just to abstract the conversation just a little bit. So what you're being introduced to today is an open community platform for conducting lots of different types of analyses. And we hope to give you exposure to all of the different capabilities. To be very, very explicit about it, this is not all the things you should be doing with observational data. Right, it's the set of tools the community has built thus far and the platform that allows us to build more tools in the future. What you're going to see, to this question, there's a lot of questions one could reasonably want to know about the effects of warfarin. And I hope that you'll get at least a a sampling of the types of things that are possible. But certainly for all of you, I want you to keep your mind open to, you are not limited by what the OHDSi analytic tool suite is. Rather, this is a capability to allow you to do certain things much more efficiently and consistently. But really, as a community, we should be working together to think about, what's the next set of features and analytic capabilities we want to introduce into this platform.
Thank you.
All right. Any other questions? Are you still excited to be here? That seemed a little lame. Are you still excited to be here? Excellent. Okay. Katie's going to really regret that she told me that I couldn't woo. Okay, so I want to give the one piece before we talk about tools that does provide a necessary grounding and the question that came up about this jargon about the word concept. We thought it would be important just to provide a very, very high level summary of what we mean when we talk about a vocabulary, because this jargon is going to permeate through all of our tools. To be clear, the vocabulary is a day-long tutorial happening there. So I'm not going to be able to cover everything for you, but I hope to give you guys that aren't familiar a gist. Just show of hands, how many of you think you are familiar with the OHDSi standardized vocabularies? Okay, like 2/3 of you guys have, so good, excellent. So you guys can correct me if I misspeak then. Okay, so hopefully this addresses the question, what the heck is this word concept? What do we mean? I'd say everything is a concept. And specifically, what we mean is everything needs to be defined in some sort of a common language so we have a shared understanding of what that is. So let's just take this Graham paper from the FDA about warfarin, and let's just look at the title and the abstract. Right? So what's a concept? I would say that what's cardiovascular? That's a concept. Bleeding's a concept. Dabigatran's a concept. Warfarin's a concept. Non-valvular atrial fibrillation's a concept. In fact, this abstract, give me 1 second, this abstract contains lots of terms, words, happen to be written in English. Each one of these needs a complete and unambiguous specification for us to be able to conduct an analysis for. It's one thing to say, I've done a study of warfarin versus dabigatran for the risk of stroke. It's another thing to actually operationalize that into, how do I find warfarin in a database? How do I find dabigatran in a database? How do I find stroke in a database? When I use the word stroke, do I mean ischemic or hemorrhagic? Or more specifically, are there specific codes that might exist in a database that I'm going to be using as proxies for what represents that medical concept? And so when we are referring to concepts here, we are talking about that we are trying to formalize that there's a medical entity that is unambiguously and universal across the OHDSi community, that there is one and only one unique identifier for warfarin. The question becomes, how do we take source data and map into that one unambiguous word for warfarin? And then how do we take these concepts, these entities, and group them together into logical groupings that allow us to do things like define cohorts, establish phenotypes, conduct analyses? And so when I use the word concept, what I'm really very literally talking about is we have a single data table in the OMOP Common Data Model. It's the table called concept. That concept table has a few fields to it, but one of them is a concept ID. That is a unique identifier, it's a big int, of a number that is numbers that cannot be reused. And associated with each one of those numbers is a description in English language of what that concept represents. Those come from existing vocabularies, things like SNOMED and RxNorm and LOINC. And so we keep track of the provenance of what one unambiguous identifier we are using across the community. But when I refer to a concept, I'm referring to these entities, and they are they serve as the basis of whenever we conduct an analysis, we are using these unique identifiers as our basis for designing our studies and conducting our analyses. And so I'm going to talk to you a little bit more about what those concepts are and the relationships, but first let me see if I still have a question.
So when you use the word concept, you're being very unambiguous. The way that data administrators use the word concept is ambiguity. We can have 23 different ideas of the Each
Yep.
one of them has a very specific definition within a context. So this is just the opposite of that?
So maybe I'll try to answer it with an example to see if this makes sense. So what we learn about the word, let me pick one here. Bleeding. Okay, bleeding sounds like should be straightforward, right? No, bleeding is extraordinarily ambiguous because we have to ask, well, what kind of bleeding? Where is the bleeding? Is that gastrointestinal bleeding? Is that all bleeding? Is that epitastis? Is that, traumatic cut my finger bleed? Like, what is bleeding? And so there is an unambiguous unique identifier for the word bleeding, and there are relationships to other unique identifiers that are also unambiguous terms, and there's relationships between those things. But that is not to say that different people might have different ideas of how they'd like to define the abstract notion of bleeding for their individual studies. Actually, quite the contrary. I would say, like, even within our own community, diabetes is a good one. I've probably read 36 studies on type 2 diabetes, and I've seen 36 plus some definitions of type 2 diabetes. And so the important point is that we have to make the data elements completely unambiguous so that they have unambiguous meaning. But the grouping of those things together to enable an analysis, those end up with words that we use to describe what we kind of mean. And different people could have different words and different compilations of things together. But what we're trying to do is make it unambiguous that if I have a database that contains diagnosis codes and they happen to be coded in ICD-9, somebody else has a database and it happens to be coded in ICD-10. We need to keep the differentiation of that my code was in ICD-9, yours was ICD-10, but we also need to be able to speak the same language for an analysis. So we have one unambiguous identifier, and ICD-9s and ICD-10s can map to that so that I could then ask a question like, go find me your strokes, and that could run in an analysis whether your database happened to have been ICD-9 or ICD-10 or any other vocabulary that's out there in the world.
Are you using the word concept the same way as they're using it when they talk about their data models?
Yes. So they being the other room? Yes. So what I'm showing you here is a very, very small subset of what they're going through in depth in their CDM tutorial. Yep. Andrew, yeah.
Maybe restate some of what you said very short way.
Please.
So that semantic interoperability is achieved by having equivalent concepts mapped to each other. So maybe the scenario you were talking about, I think if this code means this concept in this case and another code means another concept in this case, if they both mean the same concept, the CDM ensures that your analyses are mapping those same models.
Yeah. Thank you, Andrew. That was great. Okay. So again, I mentioned this is our common data model, and it's very deliberate and intentional when we talk about our data model that the vocabulary is part of the data model. And so we are standardizing not just the structure of the data over on the left-hand side, but also the content using this vocabulary. So a couple ground set rules, and since the majority of you kind of have this, I'm going to go quickly, but feel free to raise questions as you go. So what is this common vocabulary? So it is a standardized structure for storing vocabularies, plural, that exist in the wild. What we've done is we've compiled together a bunch of different vocabularies that are used across the community. And then we as a community have decided on standards that we are using across the community. So we have decided for each of those clinical domains of conditions and drugs and procedures, we've had to make a decision of what is going to be our unambiguous way of representing those medical entities. What the vocabulary is explicitly not, it is not a static data set. This is something that the community is actively working on and evolving, and it's changing, and we're releasing this all the time. If you go out to download the vocabulary today, and then you find that there's something that should be better, you can actually make that comment. It'll get incorporated in the vocabulary, and then you can download it again, and it will change. So the vocabulary is never a finished product, and so long as healthcare evolves, I don't expect that this thing will ever be final either. The vocabulary data model itself, so the data model tables that store the vocabulary, that's an eyesore in the back. More detail is in the other course. But basically what you have is you have a table in the middle, which is a concept table. It's the unique identifier in the name associated with these entities. And then we have various ways that we can exploit and make use of them, but I'll just highlight two. We have a concept relationship table, which just takes two identifiers and says these things are related in some fashion. And so examples of that might be a drug may be related to its drug class. So warfarin is a vitamin K antagonist. Or atrial fibrillation is a type of cardiac arrhythmia. So there can be relationships between entities that we preserve in this concept relationship table. And so that allows you to actually navigate this ontology to be able to explore knowledge that has been domain engineered as part of your analytic process. And we take advantage of this quite a lot. That is, if you think of this as a graph, these are basically the nodes are your concepts, and the concept relationships are your edges that connect the nodes together. For anybody who has done any graph analytics, you know that one real challenge is you got to traverse many different nodes to connect, many different edges to connect to nodes together. That can be a pain in the butt. And so recognizing that that's a pain in the butt, one of the things that we provide to the community is a table called Concept Ancestor, where we basically have done the transitive closure of that graph and provided a single data set that allows you to go from any descendant concept to any ancestor concept and be able to more efficiently navigate this ontology. The reason why I'm highlighting this right now is you're going to see in our tools, we take extensive use of these vocabulary capabilities to allow it to be easy for us to answer a question like, go find me new users of warfarin, and I can just take a concept of warfarin, knowing that there may be hundreds of different ways that that could be coded across the world's all of our databases, but we can actually create one unambiguous representation that covers all of that using these relationships and the ancestry. Yes?
Are the OMOP concepts actually separate from Snowman and ICD-9? Are they their own coding system?
Yeah, good question. So what we have done is we've taken different vocabularies, SNOMED, ARACHNE, LOINC. We've put them into one table called this concept table. And so the concept ID field, that is a unique identifier created by the Odyssey community as part of this. But that's simply because two different vocabularies could have happened to have used the same identifier, right? So ICD-9 165 has a meaning in ICD-9, but 165 also has a meaning in a CPT code or something like that. And so in this concept table, we have our own unambiguous number that's just an auto-generated number we maintain. You've got a concept name, but you also have the vocabulary from which that concept came from. You have the concept code, which is actually like preserving that ICD-9 or SNOMED identifier. Importantly, with only a few exceptions, we are not creating new vocabularies within the Odyssey community. What we're doing is we're building a Frankenstein of existing vocabularies and just putting it into a format that makes it easy for you guys to query. And so we are really building on the shoulders of what UMLS has provided, and largely we're leveraging a large share of that, and partnering with organizations like SNOMED CT and LOINC to take advantage of their resource, just putting it into a format that works alongside all those other vocabularies.
So of the relationships, who is asserting those relationships? Are you actually, is the community actually saying this code is similar to this code, a parent of this code?
Yes. So for the vast majority of those relationships, they are being asserted by the vocabularies that provide the information. So, SNOMED, for example, isn't just a list of SNOMED terms, but it's actually a graph by itself. And so this concept relationship table is just is storing the information that SNOMED CT provides. There are some cases where we've had disparate vocabularies that weren't mapped together, and so the Odyssey community has a marvelous vocabulary team that helps us when there isn't a mapping to create that, and so we as a community make those assertions. But our intention and our desire and really like what our focus is making use of information that's already out there, just putting it into an easy to query thing, not curating or generating our own new vocabularies or relationships.
Is this vocabulary set, what you're putting up there, available by itself independent of Atlas?
Yep. Yeah. So anybody can just download the vocabulary. So you could say this whole OMOP common data model thing's nonsense. This Atlas thing, I don't really like it. I just think the vocabulary is cool. And you could just go to athena.odyssey.org, download these data tables, and away you go. I think by the end of today you won't do that, but you could if you wanted to.
Is there a mechanism to then create your own custom, vocabularies on the top of that, or link this with your custom vocabulary, or create a metadata layer, separate metadata layer that you can control?
A more detailed conversation is taking place in the next room about this. The short answer is you can also, there's a table here called source to concept map. Where is it on my picture? Source to concept map, which is a place for you, if you happen to have local vocabularies that are not part of the standard, you can put them in there and the data, the analytics will be able to take advantage of that. But what we are actually trying to do is when somebody has a local vocabulary, we actually want them to share the local vocabulary with the community so that we are growing a global standard that covers everybody. So we don't want people to be having to create their own concepts. We want this to be a community effort where we can crowdsource this vocabulary activities. Yes?
I just wonder what's the best way to understand the ancestor concept and the descendant concept?
So the best way to understand it is to listen to Christian's presentation next door. But I'm going to give you a second best option, which is to show you just an example of that real quickly. Yes, Sam?
So the whole concept of popping across the graph is something that's really powerful in OMOP. Lots of powerful things, but I've described the concept of relationship table almost like a wormhole. So that you go from one thing you know to something you believe you're going to need to know related to it without having to traverse that. It's
Yeah.
really powerful.
Yeah, that's a good way to describe it, yeah. Yes?
Did I load, say, my ICD-9 and 10 concept into this? They'll all go into the concept table, right? ICD-9 being
Yeah, so actually, I'm going to cut you off and do you one better. You don't load your codes anywhere. We give you these codes. You literally are going to download field populated tables, and those tables will already have all the ICD-9s and all the ICD-10s and all the SNOMEDs and all the LOINCs and all the CPT-4 codes and all the HCPCS codes, and if you're in the UK, it'll have your READ codes, and if you're...
If I had my own vocabulary, can I just load that in as like another version of ICD-9 in a sense, as long as I have the same variables, like an identifier?
If you have codes in your source data that don't exist in the standard vocabulary, there is a way to accommodate that through this source to concept map table. It has been our experience thus far in the community that that is an extenuating exception, not the rule. And specifically, if you are saying, I have ICD-9 and I have ICD-10, so do hundreds of other organizations in the Odyssey community, and we've tackled those.
It was more about having my own vocabulary and being able to load that as like a peer to ICD-9, and it sounds like that's sort of like a stepchild table.
Yeah, so that's basically to accommodate if you've got something else that's not represented. But what we are going to focus on here is the standard stuff that everybody, we're all working from the same exact graph and vocabulary structure to allow us to do standard things. Kathleen.
Patrick, do you want to talk about the 2 billion plus concept?
Do I want to talk? Yeah, go ahead.
So to answer your specific question, if there is a case where you absolutely need concepts that are proprietary to you, which you don't want to share with the community, and you want to keep it to yourself, there is a way to do that. And that is, every concept in the OMOP CDM has an integer value that cuts off at 2 billion. So if you create your own local concept and insert into the CDM vocabulary table, but start incrementing from 2 billion onwards,
not conflict with what the community is doing. So there is a way to do it. This is the advanced version of it.
Yeah. And I would, for purposes of the scoping of today, I wouldn't worry about what you're going to do by yourself. I'd say we focus on what we can do as a community, and maybe trust me for now, but then you can challenge me by the end of the day. If it's not meeting your needs, then we can have a good conversation about that. Yes?
I think I can add something because in Scandinavia and in Denmark in particular, we only have custom codes. So we do not use ICD-10 or SNOMED. Whatever classification system is used is being derived by international standard, but it's a bit different. So we cannot go directly into any of the coding systems. And since we did that, or we are doing it for the past 3 months, having 2 billion concepts gives you the opportunity to find most of the times, if not all of the time, the exact equivalent from the vocabularies already in there. So what we did for 90-something% of our classification codes is find the exact equivalent and to create a link between what we have and what's already done.
How long did that take you?
With the tools that were described before, and I understand that the presentation next room is highlighting this, because I couldn't be able to figure it out by being present here. Like White Rabbit and Rabbit in the Hat, they do some magic and solve most of the things in a very elegant, efficient way. And then there are many members of the community or companies that can help you do that in an accelerated way. But most of the time we have no issues, even we are not even using the standard. And for the 10% that we couldn't find something the equivalent, then we use the extension, even if Patrick doesn't like it, and he would try to force us to use what's already in the vocabulary. We had some cases that we had to, let's say, innovate or create something not already there, but there is a path for that.
Absolutely.
It's discouraged.
So just to give you a more tangible example of this, if we think about the condition domain as one specific area, so what I'm showing you here is kind of an example of a graph to think about at the vocabulary level. So you've got SNOMED as a vocabulary that represents clinical entities, and SNOMED itself is a graph that has lots of relationships between low-level concepts and top-level classification systems. We have, and in the Odyssey community, we are using SNOMED CT as one of our primary standard vocabularies to represent conditions. And what that means is source codes have established relationships that map the source codes into that standard. So if you download the OMOP vocabulary, you're not just going to get SNOMED, but you're also going to get ICD-10 and ICD-9 and read codes and OXMIS and SEAL and MESH, etc. And those have relationships already curated to go from those source codes into the standard. The vocabulary also provides multiple different classification systems, so that if you want to group concepts in different ways, you can. So for example, in the Odyssey vocabulary, you can also make use of MEDRA as a different vocabulary that groups together vocabularies. So you basically have, there's a standard vocabulary, so one language that has been chosen for each of the domains. You've got classification systems, which are ways to group standards together. And then you've got source codes, which are the things you're probably starting with that you are going to preserve in your data, but also map into a standard using the vocabulary that's already provided. So to kind of go end to end for that, if we think about atrial fibrillation as that disease that was in that Graham paper, there is a single concept. All of these boxes represent different concepts that are uniquely identified terms. And so there is a concept called atrial fibrillation, and that concept has relationships to other medical concepts. So for example, atrial fibrillation has a relationship to fibrillation. Atrial fibrillation also has a relationship to atrial arrhythmia. Atrial fibrillation actually is kind of a broad term. There are more specific variants of atrial fibrillation that are also available in the SNOMED vocabulary. For example, there's chronic atrial fibrillation and paroxysmal atrial fibrillation and rapid atrial fibrillation. And so each of these individual concepts are unambiguous, but these relationships allow us to navigate, explore that space. So here you have individual concepts that are built up. But the concept ancestor table allows me to say something like, if I want to find all heart diseases, I can actually use this concept ancestor table to realize that cardiac arrhythmia is a heart disease. But if I follow 1, 2, 3, 4 hops, I can see that atrial fibrillation is also a heart disease. And so this concept ancestor table allows us to create abstract notions of ideas that we want to explore and use the vocabulary to subsume all of the different entities that might fall within that. So you've got concepts, concept relationships, and then ancestry relationships. Now, I'm showing you this particular example for conditions, but deliberately across every clinical domain, we're following the exact same principle. So if I go to drugs, for example, we have standard concepts in our drug vocabulary, which are really largely built off of ARACHNE as a standard. We have mapped a dozen or so different source drug codes into the ARACHNE standard, so things like NDC codes or GemScript codes or Multum, whatever you might have. And on top of ARACHNE, we have a large array of classification systems. So for example, we use ATC from the WHO as a classification that would give us things like drug classes that we could lay on top of ingredients. But there turns out that there's a lot of different organizations that have created lots of different ways to group drugs together on various principles. And so we've made many of those available so that they provide you alternative ways to explore the vocabulary. Okay. Actually, in the interest of time, I'm going to skip over this. In the slides, there's just a couple papers that try to make the argument that we've published and provided data for that basically says using the vocabulary is a good idea. And so read those papers. And the question that we get that Christian spends about an hour in the other class talking about is, yeah, but you're making me map my source codes into a standard vocabulary. There must be tremendous information loss. This is going to be awful. We've got papers that describe that actually the information loss is pretty low, and actually we produce the same answers when you use a standardized analysis as if you do it on the source code. You can read these papers, or for right now, just trust me. Okay, so, okay, we are starting into our break, but what I'd actually, before we go to the break, I want you guys to go to that link. I guess I'm providing the longer one, but if you already clicked on that bit.ly link, it's the same exact place we're going here, which is overview.odyssey.amazingawsdemos.com. Well done, James, with the URL for that. So I encourage you guys all to go to that website.